Hi Sophie. I wanted to make this short video to show you how I go about solving a problem using analytics, creativity and intuition. Today I'm going to be building the first part of a hydroelectric power plant. A couple of years ago I built this sluice gate to alleviate floodwater in winter. Unfortunately it's in need of urgent repair. The water is leaving the sluice gate with so much energy it is eroding the soil bank extremely quickly. Since I need to do work here anyway, I thought it would be a perfect time to tackle the hydroelectric project. My project goals are 1. Stabilize the bank and prevent further erosion. 2. Generate enough electricity to power at least a small number of garden lights. 3. Keep costs to an absolute minimum, hopefully using only recycled material. There are several parts to this project, each of which need careful planning. Sluice gate to regulate flow, the canal to transport water horizontally, preventing soil erosion, the turbine to convert kinetic energy of the water into shaft rotations. A gear system will be needed to achieve the desired shaft RPM, a generator to produce AC current, an inverter to convert that AC to DC voltage, and a battery pack for storing electrical charge. I will complete the mechanical side of this project, but I will leave the electrical side until another time. For simplicity, I have chosen a generator and will try to make my system to match its requirements. The first thing I did was create a canal or waterway. This will make it easier to measure the flow characteristics. I built a wooden box to connect the concrete pipe to the recycled gutter material. I raised the gutter until it was level along the entire length. I then went about measuring some parameters. My volumetric flow rate was measured by dropping a tennis ball in the stream and measuring the time taken for it to reach the end of the canal. Then I measured the length and cross-sectional area of the canal. The volumetric flow rate was worked out to be 0.037 meters cubed per second. The head is the vertical distance between the surface of two liquids. I measured 76 centimeters from the end of the canal. However, there is a problem with this measurement. Over the year, water levels of both the reservoir and the free stream side changed drastically. The design of my sluice has been set up to give me a pretty much constant water level on my reservoir side, so I'm limited by the water level of the free stream. Here I used some intuition and compromised for an effective head of 66 centimeters, meaning the turbine will still work when the downstream water level starts to rise. For me, a large part of this project is about learning more about pumps and turbines in a practical way. Since I have very limited tools and materials, I know that I will only be able to make something with simple geometric shapes. This leaves me with two options, either a classic water wheel or a radial impeller. I decided to go for a semi-open impeller with a volute chamber. I hope this will allow me to use more of my effective head. Also, since the axis of rotation is vertical, I can use a long shaft to keep my generator clear of floodwater. Also, it's definitely more challenging to build. I studied pumps and turbines in college, but the specific geometry and construction techniques of them were unfamiliar to me. I searched for basic designs on the internet and then went about scaling them to my application. I used a mixture of simple calculations and estimations to get the basic dimensions. I drastically reduced the number of design variables that would typically be used in a commercial turbine. I used SketchUp to quickly draw up my design and then got to work on construction. My material selection was particularly easy since I only had one option, this piece of old plywood. Well, now I just have to wait for the glue to set, and I'll finish the construction tomorrow. I tried to get this video done and sent to you by 5 o'clock today. I'm sorry, I hope you get it, but otherwise I'll send you a revised one with the completed project on Monday. Thank you very much. Have a great weekend.